All right, folks, welcome. Welcome to the second session of the Ion DTN Raspberry Pi Lab. My name is Laura Chappell, and I worked on the document. If you have any edits on that document or anything you feel that should be added to the step-by-step instructions on the document, please let me know. In the chat window, I'll put my email in here. And if you have any edits to that document, definitely let me know and I will change it. I did an update from yesterday's document. So we were on version 1.10 until yesterday. And now when you're in the venue, you will see that the link to the document, it's 1.11. If you didn't have a chance to download it, there were relatively minor edits. The big one is the image of the 6 terminal sessions. I had the wrong labeling on the right-hand side. So I guess that's pretty bad. So sorry about that. But that's all been fixed. All right, so today we are going to have the lab run by Lee Torgerson. Lee is currently managing the JPL Protocol Technology Lab, or PTL, and Lee supports the NASA DTN Readiness Program. In addition, Lee is leading the development of the Mars DTN Relay Network Operation System, which he was just talking about a moment before we started about that. Maybe he'll bring that story in again. And today we also have Samo Grasic. And Samo is our lead for the Pilot Projects Working Group and also the CEO of Late Lab. And if you're not familiar with Late Lab and you haven't seen any of Samo's presentations, you should go out to the IPNSIG library, the Zotero library. You'll see we have links out there to Samo's presentations that he's done about the reindeer herding program. It's fascinating, and it's well worth watching. These ultra low power off-grid sensor networks using DTN. Scott Burley is with us today. Scott is the main author of RFC 9171, the bundle protocol RFC, and also the Ion software that we will be installing on the Raspberry Pis today. We also have Mike Snell with us. I wasn't sure if you were going to join us today, Mike. Sorry, I should have put you on the lead slide here. Mike is our longtime acting secretary for the IPNSIG, and he's provided tremendous help in putting this event together. So thank you, Mike. He is also one of the people that revitalized, or maybe the person that revitalized, the IPNSIG, and he keeps it running smoothly. He deals with all of the new membership folks, and he really provides the interface between the members and the board as well. It's been very helpful. All right, so let's take a look at the agenda for today. We've done the introductions, and I wanted to mention that we have a Q&A window that you can open up. There's a little Q&A button on your control panel for Zoom. We're using Zoom Webinar. And we also have a chat window. If you have a question, please make sure you put it in the Q&A window so that we can really organize the responses and make sure all the questions are answered. If you pop it into chat, I might respond back and say, hey, can you place this over in Q&A? Because from our viewpoint, panelist viewpoint, we can't move them ourselves, unfortunately. So we would have to have you move it over into the Q&A area. I'm going to just start out very briefly by showing you the imaging process so that if you haven't imaged your Pi microSD card yet, you want to get that started. And then as that imaging is taking place, Lee is going to take over and launch with the introduction to DTN, or delay tolerant networking. Lee's going to be going through the One Computer Lab step by step, following that document that hopefully you have downloaded from the venue page. And he's going to go through the One Computer Lab demo, explaining things along the way, talking about the different tools and things. And then time permitting, he'll do the Two Computer Lab, which I imagine we will have the time, and we should make the time because that's well worth it. And then we'll do a wrap up at the end. So right now I'm going to stop sharing for just a moment here set up my system so that I have the Pi ready to go. And let me go ahead and share again. Okay, so hopefully you just see a black background there with the Raspberry Pi Imager software loaded in the foreground. I have a micro SD card plugged into my system with a little adapter, and we have a video on how to do this. But if you haven't done it yet, it's very simple, very quick to get it started. You're going to choose the device that you're going to be imaging the micro SD card for. I'm going to be putting it into a Raspberry Pi 5. That's what we recommended for everybody here. Although I know that we have some people that used Raspberry Pi 4 and it worked fine with the 400 model. So I'm going to select Raspberry Pi 5. I'm going to select my operating system. I'm going to go up to the 64-bit version of the operating system, the Raspberry Pi OS, Bookworm. And then the last thing is I'm going to choose storage. And nicely, they have excluded the system drives here, so you don't, by mistake, override your OS with the Raspberry Pi operating system. So I'm just going to choose that adapter. When you click Next, you are prompted, would you like to apply customization settings? I do want to do that, and I'm going to click Edit Settings first to make sure that I've set them the way I want. Once you go through and you image a micro SD card, it'll remember the settings on your system and show you those settings from last time. So the last time I ran this, I had selected to set the host name at rpi01. I put in the username and the password here. And then I chose to configure the wireless LAN. I typed in the SSID, typed in the password here. I selected my wireless LAN country. And if you don't fill out some of these things, when you launch the Pi with this micro SD card in it, you'll be prompted in the upper right-hand corner. It will say, oh, you need to give me the password for the wireless network and those kinds of things. Or you need to give me your country code settings. I'm going to set my locale settings. So I'm in Seattle, so the time zone is going to be Los Angeles, America time zone, and my keyboard layout, because the default will be UK keyboard layout. And so I don't want to have that. Under services, I am always going to go in and just enable secure shell by default. And that means I can use something like PuTTY to connect over to my Pis. And the password authentication, it will just be the user's password that you configured on your general, under the general tab there. At this point, I'm just going to click Save. And now I'm ready to say yes, that I want it to apply the OS settings. Final prompt to make sure I'm not overriding the wrong drive. Let's see, questions. Okay, you got to remember to put your questions, if you don't mind, pop them over in the Q&A panel, because that way we can respond with a Q&A document. We can build a most common questions document from that as well, and we make sure that everything is answered. Okay, so at this point, I'm just going to say, yes, go ahead, let's start. And now I'm just going to sit back and wait until it tells me that it's successful. When it's done, take the micro SD card, pop it into the Pi, and power it on. We have on the page, the venue page, we have the second video that goes through the updating and upgrade process for the Raspberry Pi. And what I just did right now is on the first video on that venue. Look at the venue page. Also, if you get lost in here at all, or you didn't have a Pi available to you, and you really want to go through the labs, there's a video of the entire one computer lab setup on the venue page here. So you can actually download that zip file and pull that offline and run that video. Okay, now that that is done, I am going to go ahead and stop sharing here. And I'm going to hand it over to Lee.
Okay, thank you very much, Laura. I've got, while everybody's imaging their Raspberry Pis, can take 10-15 minutes just to burn the micro SD card. I'm going to go through some introduction that you may not be familiar with. One of the premises of this lab was that we wanted to be able take people who are not Linux adept, people who are, which includes myself sometimes, people who are not Linux adept, and people who are brand new to this field. There may be high school students, for instance, that just got their first Raspberry Pi, and they want to start playing with this stuff. So we're going to make it fairly simple and keep it fairly rudimentary. And as I mentioned yesterday, I think this whole DTN business and the Ion software has as many dials and knobs and switches as a 747. But today we're only going to try to learn how to start up the engines, taxi out to the end of the runway, take off, turn around and land, and declare victory. And then everything else afterwards is going to be you've got a pointer to where to go. You've got contacts that you can email and ask questions, and we'll be more than happy to give people assistance as required. So with that, let me get into my presentation first. Oh, Laura's got to let me into the sharing department, and I can share this guy. Move it in front of me so I can see it, make it full screen. Okay, so the first thing is, why do we need networking in space? A lot of people, especially if you're terrestrial internet people, most people start out with learning how to use the internet and program IP and so forth. The question comes up, why do we need networking in space? And especially with spacecraft missions where they've only got one spacecraft, they go, we don't need any networking. What are you talking about? It's only one of us. Well, there's a lot of reasons that we'll go through. Pretty soon in the near future, if all goes well in the world and the land of budget allocations, we're going to have so many things in space that we don't know what to do with. And the current Apollo era link protocol systems or whatever is that every spacecraft has a single link to the spacecraft from the grounds, from the deep space network up to the spacecraft or wherever. And they're all put together by individual team members that almost like telephone operators where they hook up a circuit just for your spacecraft. Well, that doesn't scale. We've got lots of things in the near future, in the next 20 years planned to be in space, and that's not just the United States. That's the entire world. That's JAXA and ESA and ISRO and Roscosmos and everybody, and the Chinese. Everyone's going to be up there, and we want to be able to network these things so that we can share communications links and we can manage the scale of the amount of people that are out in space. So why can't we just use regular old internet? Well, think about this. The key assumptions that went into designing the internet in the first place back in the day was that networks are richly connected. All your IP protocols assume that, or applications assume that. That networks have a short delay. It's only a few milliseconds from here to New York or from here to anywhere else in the world. The internet on the Earth assumes that the data links are symmetric and bidirectional. So you get 100 megabits one direction, you can get 100 megabits down if your internet service provider is generous. So they're symmetric and bidirectional links on the Earth. They're also over fiber optics and engineered to have extremely low, 10 to the minus 12th or something, bit error rate, extremely low error rates. And that when things don't work, it's usually because of congestion, because too many people are trying to log on to go through a router to get somewhere, and that router just gets overloaded. And when IP networks, when the router gets overloaded, it just throws the data away. It doesn't know what to do with it, so it just ignores it, which is how denial of service attacks work in some in some cases. Anyway, it's congestion. So the genius of Vint Cerf's and his colleagues' design of TCP/IP was that when a router gets congested, it'll automatically the people using that router, if they start seeing their data is not, their acknowledgements are not coming back, the they assume that a router is congested somewhere in the path, and the good citizen thing to do, if that is the case, everybody drops their data rate in half. And if everybody hitting that router that's congested drops their data rate in half, and then maybe even in half again, um, it'll clear up the congestion, things will start to flow, and then there's a slow start mechanism that creeps the data rate back up until you have loss again. So it's a self-regulating system, which is just pure genius. It was a great design for all of the four items above, or three items above. We also assume in the internet that network nodes are trustworthy, which is to say that routers usually are kept in router closets under lock and key, and they're not subject to malicious attacks. Knock on wood, other hackers notwithstanding. And the final thing with the internet is that all the protocols and all the applications assume that the connection is end to end. If I wanted to talk to Samo in Sweden, for instance, I might have 10 or 12 routers I had to go to get from here to Samo, and Samo's not going to answer me back until I've got a full connection all the way from one end to the other. And vice versa. He can't respond to me until he's got a full connection one end to the other. That's cool, but none of that works very well in the space environment because we've got a sparse network. We don't have very many routers flying around in space at the moment. Most of the links, radio links in space are asymmetric. You got a large bandwidth coming down because you've got 34-meter and 70-meter dishes on the ground able to pick up the signals. And the spacecraft have 1-meter diameter antennas. And so you end up getting a lot of data down. You get a trickle of data going back up. So it's asymmetric. Sometimes, depending on the ground station you're talking to, it's half duplex. The station can either listen or it can transmit, but not both at the same time. And in some cases, depending on the situation, you might have unidirectional links. So you can see none of the internet stuff works very well under those conditions. Then we have loss due to corruption, not congestion. So if you lose some data because you're working in a high frequency band like Ka band and a cloud goes by and it soaks up the signal and you start losing things, you don't want to saw your data rate in half because that cloud's going to go past pretty quickly. So you have to have a different treatment for loss of data other than the TCP paradigm. You also have loss due to orbital geometry and antenna pointing errors. The spacecraft goes behind the planet and it's out of touch for 20 minutes or 40, whatever the orbit is. And if you can imagine from Mars, which is, millions of miles away, trying to point the antenna exactly right to get to the Earth and to get to that ground station is quite a challenge sometimes. It's 8 minutes from here to Mars on a good day and 20 minutes when it's on the other side of the sun. So that could give you a 40-minute round trip time. So you couldn't do a TCP connection where you do a send and then wait 40 minutes and then you get an ACK back and then you do the next step, and it would just take forever, of course. And then finally, the space world is insecure because you don't need a 34-meter dish to hack lunar comm links at the moon. Because you walk outside, look up, go, oh, there it is, and you go in your garage and bring out your ham radio Yagi and point it at the moon and start working away trying to see what you can pick up. And that is guaranteed to happen all over the world. So what does DTN look like? The first design point for DTN was to make it an overlay network so it can run over any kind of network underneath. Because sometimes you've got IP networks and sometimes you've got space networks on board a spacecraft or in sort of a inside of a data center. I don't know, maybe not a data center, but you might have RS-232 or 1553 links for your networking inside a particular area. So we made DTN so that it was agnostic to what was below. You put in little adapters in between as you need them. and make it an overlay network. And so up here in the application space, file data, telemetry, video, that sort of thing can go right into DTN bundles. And then the DTN has the feature of managing routing, knows where to send it for the next bundle, for the next hop. It has security built in, so you don't need IPsec tunnels or TLS. With DTN, you can encrypt the individual bundles. In fact, you can encrypt portions of the bundles with different encryption keys if you've got multiple users that need to do that. And then if the next hop isn't available, you've got storage. So you just wait until the next hop comes up. So if I'm trying to send something to Samo, if I'm using DTN and I can't get a route all the way from here to Yulia Technology, Institute of Technology or something, if it was DTN, it would go as far as it could go. And then when that link came up to the next hop, it would go, oh, there you are, and take it out of storage and send it along. So those are kind of the high level features of DTN. So we have an implementation that's called ION, and since it was an interplanetary overlay network was the reason for the name ION. It consists of things in blue here, and if this is like a COM stack, you'd have applications up here, and DTN ION comes with a number of DTN aware delay tolerant applications. It has the bundle agent, which includes the bundle protocol security. It has the program storage, bundle storage, which can be all in RAM, or you can have it on hard disk or non-volatile storage, or both. We're going to use just volatile storage today. And that was so your spacecraft, if your spacecraft rebooted, God forbid, because that's the strikes horror into the, or terror into the hearts of mission operations people when the spacecraft goes into safe mode because the computer rebooted. If it starts back up again, you could recover your state from the non-volatile storage if you've arranged for that, and it could start where it left off, essentially, is the idea. Then underneath, you've got to be able to talk to the physical interfaces. And so we do that with the CCSDS telemetry protocols, AOS, TMTC. We can do TCP and IP, TCP IP and UDP IP. We can do whatever et cetera is. And we ship with LTP, which is the Licklider transmission protocol. And that's akin to TCP for deep space links. We had reliability links from the surface of the planet to an orbiter. We got reliable links with TCP all over the terrestrial internet, but we didn't have any good reliability, automatic retransmission request reliability for deep space. So we include this LTP protocol. I'll show you where the documentation is when I get to the other demonstration, but I think these links are in the reference material somewhere, but we'll see that in a minute. So after you install your operating system, and we're going to install ION, download the package, compile it, install it, and we're going to start it up with a script. And I just wanted to explain real quick what this script was about. Since ION was designed to be essentially be a very tightly, it's written in C, and it's very compact and it's very efficient, and was designed to be able to be on board spacecraft or embedded systems or small computers, because that's what, you can't have something that's written in C++ and compiles to 12 megabytes and hope to get that, or 1200 megabytes or something, like a lot of today's software. So ION's very compact. And the thing that spacecraft require us to do is we have to define a memory block that's in red that the spacecraft designers tell us we can have. And we cannot step outside the boundaries of that red maximum memory available, because there's no way we want to have a program crash or something happen in this ION working space that goes outside of the allocated memory, no malloc. If it goes outside of the allocated memory and crashes the spacecraft software, we'd all be looking for jobs at McDonald's, and we don't want that. So the first thing we do is we run this ion administration program that takes commands that define what this container looks like. We tell it what the working memory size ought to be, how big the heap storage space is for the spacecraft or the simple data recorder to store the data that is going to be sent out later, perhaps. That starts up the essential background processes that have to be running. If we were using bundle protocol security, we would install the cipher suite information and what keys and so forth. We're not going to do that today, but that's capability. Same thing with LTP. You define if you're defining an automatic retransmission protocol to some planet that's 40 minutes one-way light time, you're going to have a different automatic retransmission scheme or plan as opposed to if it's only 10 light seconds away. And so you set up the LTP spans, they call it, separately depending on the occasion. And it's kind of a point-to-point thing. That's a homework assignment for later on. We'll learn about LTP. Then we say, okay, we got this skeleton. Now we got of the bundle protocol, which sits up here in this blue area. We got the skeleton of how the bundle, how DTN is going to work with the bundle protocol and BPSec and so forth. And now we're going to tell it what services and protocols and input and output services it needs to load. Because we can't put everything in all at once because not all nodes need that. If your node only has TCP and nothing else, then you don't need a lot of the other protocols and space links and stuff like that. So that's very tailorable, if that's a word. And so the BP admin program does that. A little aside here is that the internet has a socket which consists of an IP address and a port number. And of course, the IP address is how you get your IP packet to wherever it's got to go. And when it gets there, the port number tells the TCP IP stack what application to give it to, because the application will start up and register that, hey, I'm listening to port 22 because I'm SSH. So the moral equivalent in DTN is an endpoint identifier, EID, and it consists of an IPN number, which is the node number, and that in your mind, think of that as the IP address. And then it has a service number, and think of that in your mind as being the port number in a socket. So IPN address 1.3 is a node that has got a DTN address of 1. It might be 15,000 or some other larger number, but it has its specific IP number. And then IPN number. And then it has a service number. And like 3 is we run a program I'll tell you about later that we run it in the background that echoes things back so that your bundle protocol ping works, because we don't have ICMP in the DTN world yet. So you need an echo program on the other end. And so the echo program starts up and tells bundle protocol, hey, I'm service number 3. So if anything comes in addressed to service number 3, give it to me. So that's what BP admin does. CCSDS file delivery protocol, we'll kind of use it in the background. We won't go into that today, but think of it as the DTN version of file transfer protocol, FTP. And it's been in use for years in other spacecraft missions, and it's well known and well used in a lot of places to transfer files. And then finally, you give it the contact plan, which is kind of the DTN equivalent of routing tables, if you will. The contact plan lays out, since we're working with spacecraft usually, you can talk to that spacecraft from this time to that time and then disappears for 45 minutes or behind the planet. And then you have another contact that you expect to come 45 minutes later, and then you can lay all that kind of timing out in these routing tables. In the Mars program, for instance, the standard deep space workings says they change their schedule, they upload schedules for the next 2 weeks so that if something happens on the ground, and you're out of communication for a while, the spacecraft still has 2 weeks worth of marching orders to figure things out. So that's kind of the scale of what the global, and I just called it global.rc is for the name of the contact plan. We're going to show you some simple tests where we do a ping. And as I mentioned, I just read an interesting article last night about written by the fellow that invented ping on the internet in the early days. And he wrote some software. He had to write an echo application because a lot of the implementations of internet in the ARPANET days didn't have it didn't have ICMP. So he kind of wrote something and he gave it to the BSD, the Berkeley Unix adopted it. And so ICMP has echo built into it. We don't. So we have bping. It sends a bundle to the other guy. Whoops, sorry. Sends a bundle to the other side addressed to the BP Echo program. The BP Echo program goes, oh, hey, I need to send that back, and it echoes it back. And then this program will do the timing just like regular internet ping. So then we're going to show you how telemetry might work. There's a BP driver and BP counter. Samo had recommended yesterday BP source and BP sync as alternatives, but we'll hold off on that for the time being. This sends a series of bundles that you specify the size and how fast they're to be sent to the other side. And then on the other side, there's a counter program that just counts up the bundles. And then after it counts a specified number of bundles, it returns you a measurement of what the throughput was across the link from node 1 to node 2. And then finally, we've got a file copy application because at least that's something everybody wants to have. Initially, they don't have time to learn about CFTP. Well, they can use BPCP, bundle protocol copy. And on the other side, you can run this daemon, the BPCP daemon, to catch that file, and you can send the file over, and we'll show you how that works. So how do you know what's going on? There's two things. There's the ion log, and everything writes error messages and status messages and everything to the all the different all the different applications, and the ion software writes to this ion log file, which is in the operating system. Usually it's outside of DTN, so you'd have to SSH in to see it, or you'd have to make arrangements with spacecraft telemetry like we've done before in the past for the spacecraft to send the logs when you want them. But we have a single ion log, which is efficient, and everybody writes their sad story to the ion log if there's a problem. So I'll show you how that works when we get there. Then we have some debug characters called watch characters, which trace the data all the way through the DTN stack on either end. And you can, these are optional and selectable. You don't have to show them, but when you're starting up, they're good to look at because then you can figure out what's going on. So the way they were designed by Scott is that it's just alphabetical. A new bundle is stuck into the top of the bundle protocol. And then when the bundle protocol puts a header on it and it's ready to send it to the lower, the output of the bundle protocol, the convergence layer interface down to the next layer, it puts a B out, and then when the next layer is ready for it and it actually hands it off, it'll print out a C. And then when it gets something, the bundle application it'll say Y, I got a bundle, and then Z, I've sent it up to the application that wants it. And so what you'll see in the window is you'll see, if I run bping in one window, application window, it'll print out an A that says bping has just got a bundle from me. The bundle protocol will send a B and a C when it's ready to send that out. Then it goes to TCP/IP today, and it doesn't do anything for us as far as watch characters. On the receiving side, you'll see it says, oh, Y, I got a bundle, and Z, I gave it to the Echo program. And then the Echo program is going to put out a little indicator that it is going to send something. And then it will, so it'll have YZ from before, then it'll have a dot. And then when it sends it to the bundle protocol, it'll go ABC, just like we had up here. meaning it went to TCP, and then on the sending side, you'll see the YZ show up that it got the response. And then you'll see a bunch of stuff we'll show you here on what the bping program does with that information. So, I'm sorry, I'm hearing a phone ring in the background. Thought I had all my phones turned off. So, okay, now I think I've covered everything on this, so we should get involved or get on to doing some hands-on ion work. And I hope at this point everyone's got their ion node, their Raspberry Pi node up and running. And then I'm going to share. I want to share my Raspberry Pi node. Okay, one little trick that I didn't do yesterday is when you start your Raspberry Pi node up, you're going to see your username and the name of the computer, RPI01. And if you list the directory with ls, you'll see you've got a handful of standard directories that everybody gets, and there's pretty much nothing in most of them. One trick that I didn't do yesterday was that if you have a internet browser, you should have both of those. And I just clicked up here and somehow Google got to them and Chrome came up. So if you do that, you can have an actual link to the ION documentation. And so it's ion-dtn, and there's some sort of repository called readthedocs.io, and then English, and I'm not sure if ION documentation is in any other language at the moment. And then ION open source 4.1.3s is what we want. And down here, when you open that documentation, there's a pull down, and there's a new implementation that's just been released called ION open source 4.1.4, and it's alpha 1. So it's got some bug fixes, mostly in BPSec, and that's one of the reasons we're not using BPSec today. But if you end up at this point where it says 4.1.4, use this little pull down to get yourself back to 4.1.3. And then in this documentation, I'm not going to go through it, but there's a quick start, deployment guide, there's all sorts of information. One of the things that we're trying to do with ION is that we used to include a lot of documentation with the ION distribution, like there's something called ion.pdf you'll see when you download it. Well, ion.pdf is version 4.0.1, hasn't been updated since. And so we've decided that what we're going to start doing is we're not going to be putting documentation for ION in the actual ION repository. We're going to be putting ION documentation in the online documentation place, so we can keep it updated and only have one set of documentation to update. Okay, with that in mind, the next step in the process is called step 2 in the documentation. I printed it out. Photo op for Kathy. Yeah, I can't make that. Gotcha. So, I'm sorry for the interruption there. So step 2, first thing we're going to do is we're going to get a terminal window, and we're going to you click up here with that first little terminal window on the left on the top bar, and that'll open up a terminal window. The nice thing about terminal windows is they're free, and you can just open them up and close them when you don't need them anymore. So open up a terminal window, and I'm going to expand this a little bit to make it easier to see. And this is the horrible part. And I decided a lot of people are going to have to type this stuff in instead of cutting and pasting. So I have to type in WGET space HTTPS://GitHub. It should be github.com. /NASA dash JPL /ion dash DTN slash archive. I'm going to go have a talk with somebody about this link. Dash refs or /refs /tags, and then ignore the backslash. That's just a line continuation in case you cut and pasted this into your terminal. It would allow you to type in ion open source as a second line. But I'm just going to go /ion dash open dash source dash 4.1.3s, and it's .zip at the moment. So this is what you should see, and it's downloading the zip file for your ion source. And it's 74 megabytes roughly in size. So that takes you to the bottom of step 2, page 7, where we then go unzip. And I forgot to remind everybody, in case you were in one of those other directories messing around, see what was there. Make sure you do this when you're in your home directory. In fact, every time you download anything, make sure you're in your home directory today. So we're going to unzip. And if you're not familiar with Linux, or you can type in a few characters, and if it's already on your hard drive, you hit the tab button, and it should fill in the rest of the line for you, which is a very good time saver. It also is a very good hint that you're in the wrong directory if you're trying to do something and the tab button doesn't fill in. So if we do this, it unzips everything. And now if we list, you'll notice, ta-da, we've got ion-DTN, ion open source 413s as a directory. And so this is kind of a little bit out of the flow of consciousness, but the order that it ended up in this set of instructions is we have to set an environment variable to do ion on the 2 instances of ion on the same computer. And that's because when you get 2 instances of ion on the same computer, they're going to talk to one another over localhost. But ion normally assumes that there's one data recorder, one heap, one set of memory for all the data. And it sets that up automatically in the normal use of ion. But if you're going to set up 2 instances on the same computer, like we're going to do, we've got to help ion out by telling it, okay, you're going to have 2 memory places to go look, and there's going to be 2 implementations of ion, and we're going to keep track of that in a little file that's going to go in your home directory. And in order to help ion out with that, we have to set an environment variable that gives that path. So the first thing we're going to do is nano dot, and it's one of these files in your root directory that you don't see unless you go ls space -a to see everything. But we're going to find the bash resource or running configuration file with an H. And it looks like this. Now, if you're not familiar with Nano, it's a very handy little text editor, and you just scroll down with the arrow key. And what we're going to do is we're going to scroll, just ignore all this stuff. Gives you the colors for, when you do your listing, and the yellow and blue, and you don't need to worry about that now. We're going to go all the way to the bottom. And since I did this yesterday, we're going to type in this line right here, export ion _node _list _directory. And you're going to tell it that means that the path to the directory is in your home directory. So the path to the path identifier of ion node list directory is your home directory, and you don't have to actually hit return because it doesn't matter there. To write it out, instead of saving, with Nano, it writes out. So you go Control O, and that writes it out. It tells you just to be if you want to write it out to a different name, you could, but you tell it, okay, just hit return. I want to write it back to the bash RC file. And then it says it wrote 114 lines, and then you go X for exit, and that quits you out of that. Now, this terminal was opened with the old bash resource file, and so it doesn't know about the environment yet. So if you go source and tell it .bash rc, this terminal software actually goes out and it rereads that bash rc file and resets itself to whatever you had just changed. And we can check that out by doing PRINTENV, which is print environment. And you'll see all of this cryptic stuff. And somewhere in the middle, you should see right here, you should see the node list driver or directory is /home/ whatever your username is. In my case, it's Torg, so I don't like to type. So my username's Torg. And the security people that hate me because my password for this Raspberry Pi is PSWD. That's how lazy I am. That shows that we're all set for the environment to be able to run two nodes at the same time. Okay, let's go to the next step on page 9, which is step 4. And I can use this same window. The first thing we got to do is Ion has some build dependencies. When you compile Ion, it needs some libraries that Raspberry Pi might not have. And if you're running other Debian or Ubuntu or other Linux implementations, you need to do this just to make sure. So the thing you do is you go sudo, which means you're now running as root. You do apt, which is the way to download software and install and update software. And you tell it to update, spell it right, update. And then when it does that step, you're going to say, oh, and by the way, do another step. Sudo apt update just updates all the directories that your system uses to go look for external software and to make sure that the repository you're going to want is available and the current version is what it's going to use. So then you go sudo apt, and now you tell the apt program to install some stuff. And the things we need is this big list of automake, autoconf configuration, the library tool, libtool, ignore the the backslash, the library M4 and the library GCC so we can compile and then make so we can actually make software. We're running to C. We're going to evolve into CMake to make this a little easier in subsequent releases of Ion. But for right now, if we do this, this is what will happen. And for the most part, we've already the Ion already. I mean, sorry, Raspberry Pi, the latest OS, pretty much already has all this stuff. But I run this just to make sure, so we can see that we didn't upgrade anything. We're pretty decent in our configuration. So let's build Ion. So to build Ion, when you compile software, you usually want to be in the directory that software source code lives. So we're going to go CD, and we're going to go capital ION dash and hit that tab button. And that's our new Ion. That's our Ion source directory that we just unzipped. And if we go into that and you list it, you'll see there's tons of stuff in there that read the doc requirements. I think that's where Jay put in the warning that go read the online documentation and pay no attention to the some of these other. In fact, I think he might have even taken that out. The old Ion. Yeah, he took that out. The old ion.pdf doc. So this tells you to go to that website to get the current documentation. So one thing is that when you run the compilation steps, the first thing you do is configure. Well, we don't have a configure file in there because this is distributed without knowing what implementation you're going to be configuring for. So you have to do your own configure file. Well, fortunately, there's this thing called auto reconf, and it's auto RECONF. And then for some unexplained reason, -FI needs to be in there, and hit return, and it'll go through and it'll look at what you've got, and it'll look at what files you need to have available for the compilation step, and it'll fix it up for you. So now if I ls, you'll see there's a configure file in that directory. So that's what we need. So the next thing is, the next step is where it says /configure. And so you do that and you sit back and watch as it checks for all the things it needs, and it configures and creates a make file. And the make file is what the make program uses to actually go out and compile the software and make the executable object files available. So the next thing we do is a very simple step called just make. And here it goes, and it's compiling all these stuff. You can see the little libtool. It's compiling things out of libtool. It's compiling things out of some of the other libraries, CFDP. This goes on long enough to go have a coffee, and it's probably like a 5-minute process. And I think it puts error messages in red, and so you'd spot those pretty quickly. Scott Johnson had recommended yesterday that if I was smart, I would do make -L4 or something. I've forgotten the exact terminology that Scott had suggested, but it means use 4 cores to do this. Right now, it's cooking away on one of the 4 cores in the Raspberry Pis. So you could speed it up if you're doing this all the time. It'd be worth looking at the man page. That's another thing for new people to Linux, is that every command you type in Linux has a manual called a man page, and you just type in man space and the name of the command, and we'll show that to you later. But man and the name of the command will show you all the options and all the things you can do with that command with the correct letters tacked onto the end of the command. Okay, so it's almost done. Next time I'll take Scott Johnson's advice. Yes, ma'am.
Do you want to take a 5-minute break now?
Oh, that would be a good idea. Yeah, why don't we just take a quick 5-minute break, and when we come back, this will be ready to go.
Okay, I'm going to take over sharing, and I'll put a timer up for a 5-minute break.
Wunderbar. I'm sorry, you step out in the hallway and 15 people attack you and have questions. And what about this?
They want your autograph on stuff and take selfies with you.
So actually, I had to go downstairs and get a picture. So we're giving a picture to a retiring person, and so I had to get in the group picture. So that was a timely break.
You're a celebrity.
Okay, so we did make, and this is the part sometimes I forget, is that I get all this, I get to here, and I think, oh boy, now I can play with Ion, and so I start trying to run Ion, and well, I haven't installed it yet. So the next step after make is you got to go sudo, tell the make program to go install it. And so it goes along, and there's some minor warnings that we'll ignore because they don't mean anything at the moment. And when you finish installing it, the next thing you got to do is you've got to tell the operating system how to link to the new libraries that you've installed. So you go sudo lb config. Ta-da! Okay, that finishes up page 9. And now we're ready to do some Ion work. First thing we're going to do is all those configuration files that I talked about, we've already got them set up and already configured so that 2 instances on one computer will work, but we got to go get those. So as I said earlier, when in doubt, CD to your home directory, which is the tilde sign. And you can double check, make sure you're in the home directory by seeing that you're in the home directory there. And so we've got to go get these local node configuration directories, which contain a bunch of files that I'll show you. So we're going to go wget, this is so painful, dash capital O, kind of looks like a zero, capital O, and we're going to get lnodes.zip, and it's going to be https :// bit.ly /725 -l nodes. Okay, and that ought to go get the things that we need. And so now we've got a file we list. We've got this lnodes.zip file. And of course we unzip lnodes.zip. And it does that. Now if we list the directory, it's one thing that's kind of strange. And this, I won't get into this, but the permissions get set to whatever your uname settings are. It's all very complicated, and I won't get into the details. But when you use zip instead of tar and gzip and the regular Linux kind of things, it sets permissions kind of in a strange manner. If you go ls minus long, L for the long listing, it'll show you the permissions. And normally your directories are DRWXR, and no writing by any of these people, but you can read and execute. And when you unzip things, it for some reason it just sets everything like 777. It sets all the permissions to that, and that doesn't hurt anything. It's just an explanation of why the directories show up as kind of green. Now the next thing we need to do is and I'm going to just to show people that aren't familiar with Linux and Raspberry. If you click on these little folders up here, that gives you a regular text, a GUI graphic user interface look at what you've got on your computer. And if you've goofed up and downloaded something in the wrong folder, you can just go in here and you can drag and drop just like your normal, if you're used to Macs or Windows, just like your normal way of doing it without the command line copy and move procedures. So the next thing we're going to do is on the following page, step 7, set up some terminal windows. Now the trick to terminal windows is I want to have 6 terminal windows because I'm going to run ION IPN node 1 in the first 3 on the left and node 2 on the 3 on the right. And so the little trick to this, since there's not a good window, there's not a good terminal program that can do size and position on terminal windows that comes with Raspberry Pi. You could install a whole number of different solutions, but for right now we're going to do it the hard way. But the trick to the hard way is to do this. Go into Edit, go down to Preferences, and one thing I didn't mention earlier was that you probably will see monospace regular 10. You want to, if you want to bump that up to whatever your eyes are comfortable with, here's where you do that. You can just change it there. But if you go to Display, it'll say default window size 80 by 24. And what I've done to size for this 1920 by 1080 display is I trial and error found that 71 and 11 works pretty well. And so if you say 71 and 11 there and then say OK, then what you can do is, like I say, terminals are free. You can just close that guy. And the next time I open a terminal, it's got a nice size. So if I do that and I want 6 terminals, so I go 1, 2, 3, 4, 5 more. And I just take these terminals and this is a little tedious, but it's not as tedious as having to resize them as you go. So I'm going to move these terminals so I've got a 3x3 array. Okay, now the next thing you need to do, and it's a little out of, let's see, page 12. Yeah, Laura's got this laid out for doing everything in window A, window B, and then window C, which would be on both machines. What you want to do is we're going to first off change the directory, and I'm going to do it in all the windows all at once because we want to be in the local, the L node 1 directory for each of the 3 terminals on the left. And if you highlight L node 1, that CD command, and you use your middle mouse button and click in the other 2 windows, it'll just copy that. And then you can go back up here and you can just go return, return, return. And then on the other side, we're going to make this change the directory to L node 2. Highlight that guy. Click, click, return, return, return. Now we got all windows set for the 2 different nodes, the node 2 on the right, node 1 on the left. When I mentioned the zip program messes around with the way we did it this time, it messes around with the permissions. The ion start script does not have executable write privileges or executable privileges yet. So we have to do this command that changes the mode of permissions. You have to do this on in each directory. So we go chmod, add the execute flag to the program, the shell script called ion start. And only need to do this once on either directory. So if I do that here and I do that here, and then I ls minus l ion start, just to look at that one file, you'll see that now it has executable privileges, so you can run it with a // and then the name of the file. So with that, we can continuing to reference the diagrams on page 12. We're going to start ion in the 2 top windows, one on either node. And so first I'll start ion by going / ion start. And you'll see a bunch of messages that pop up. Now, what I'm gonna do one more terminal window. Just this is not in the directions, but I got to thinking after yesterday that it would be good to go through this real quick. Ion is running now in node 1. And if I go PS AUX to see the processes that are running on this computer, and if I was clever enough to have made the window big enough in the first place, you see everything. So up here, these are all the kind of normal processes that Linux is running in the background, or running to make your windows and so forth. And when you run ion, you'll see here's a bunch of terminals that I just did. And then you'll see that when I run ion, you've got RFX clock, BP transit, IPNFW, all these kind of DTN looking things in there, and a TCP connection trying to talk to somebody. A local host is trying to talk to port 4556. And so that's how you know ion is running. Well, how do I kill ion? Well, the best way of killing ion right now is with a script that's built in and it's installed called killm, which is short for kill memory. I learned yesterday. If you do killm, it kills all the processes that ion has running. And then if you do a PS AUX again, you can double check, and yep, sure enough, none of the ion stuff is running. So if you ever start Ion twice on the same node because you forgot it was running, you get all sorts of weird error messages, and it gets all very confusing very quick. And the best thing to do is you pull the ejection lever and pull the face curtain down to kill them and bail out and start Ion over again. Then there'll just be one instance running. So over here, we'll do same thing. We'll do dot/Ion start, and see the normal kind of things. Well, how do you know those are normal? Well, let's do another thing real quick. I'll show you what the full Ion log looks like. And then I will remember that I need to be in the L node 1 directory, because that's where the Ion node lives. And then I can list it, or put in the less program. For non-Linux people, the less program is the cat program sends all the text to the screen in one fell swoop. And the less program just does it a page at a time, and you hit the space bar to get to the next page. So when Ion starts, it just puts into these notations. We've done all this, and we don't use multicast, and we're running TCP. And oh, what it says, can't connect to TCP socket. Oh goodness, well that was because I started it over here first, and I didn't start it over here for a while. So there wasn't anybody to talk to. So it tells you that it's refused. But it keeps going. It runs the admin program, and it runs all these other things that you saw. And then when you hit return again, it takes you to the next page, and it gives you a status report of what bundles it's stored up to. If it read them out of non-volatile storage, you'd see the number of source bundles, the number of bundles waiting to be forwarded, the number of bundles, all these statistics. You can do the man page to see those. But since we didn't start with a non-volatile storage restoring the Ion memory, the heap space, these things are all basically going to have zero counters. And so that's a detail that you can, like I said, look at the Ion docs for that. And then it says, okay, I'm finished doing all this stuff. I've stopped all these administrative programs that I had to start up to get Ion running. And then there's the end at the moment. I'll go Q to get out of that. Now over here, so what I usually do is I use a tail is a command in Linux that allows you to show the tail end of a file. And if you go -F, it follows the tail end. So instead of just showing you the last 10 lines of the file, it'll follow. So it'll pop up a new line every time a new line gets written to the file. And so I'm going to tail ion.log. And what that does is it shows me what the last entries are. And while you're running things, if there's an error, you look down here in the middle windows and you see the last part of the Ion log, and it's very convenient to just watch it as it happens and figure out what the error is. And if I go tail -F .log over here, we'll see that. Now, I'm going to just double check to so he couldn't connect in the other direction. Okay, Q. That is making me somewhat suspicious because both nodes should have connected to one another over TCP. So the first thing we always do is we check with bping. And if I do bping and I do C1, so I'm just going to send a single ping bundle over, and then I do Q0 so it quits when I want it to right away. And I go from my node, which is IPN 1 dot, and I'll use service 2 because that's not assigned to anything. BP echo is assigned to 3, service number 3 on the node 2 side. So I'm going to go to node 2, IPN:2.3, and hit return. And it says SDR profile not found. Okay, so of course this worked fine the last 42 times I've done it.
Of course. When I look at that log file, it looks like the node was stopped. It looks like everything was turned off. So that would maybe explain why there isn't anything running.
Yeah, I'm gonna do cat tilde slash dot bash rc. Make sure we still have, yeah, right at the bottom, export the node list. That's cool. And then ls tilde, and I've got ion nodes. And if I do cat ion, this is troubleshooting on the fly. Oops, ion. Yeah, it says that ion 1 and ion 2 have 2 separate memory spaces with, this is kind of a key to the memory spaces. So all that stuff looks good. So let's just go back. Let's go back and start over again. We'll go kill M just on both of them. So this is good to demonstrate how you handle little anomalies like this. So if I just do dot ion start here, and if I go dot ion start here, okay, those all look good. The ion log, so you can choose to erase the ion log every time you start ion, or you can just have a running log that just grows without bounds. We always erase it when we start ion. So right now the tail doesn't know what to be looking at, so you have to go Control C and tail it again. This looks better. Control C and then tail that. So what happened is we started this guy before we started the one on the right, and it would have said up in the log that it couldn't reach the TCP connection to this one. And so, but finally at the end, when I started this guy later, this guy being on the node 2 on the right, now you can see it says, connected to TCP socket 4557, and it looks like TCP CLI is all happy in both directions. And so now if we do bping, you'll see that it happens very fast. So the bping application put out an A, and this is just a function because I ran it out of this window instead of the ion window. So it put out the A, and then the ion window said BC. I sent the thing down to the TCP, and then over here it said, well, YZ, I got it. And then, but I'm supposed to send it up to the echo program. Well, that's in the background. So the echo program writes a little dot to the screen that the ion's running in. And then it goes ABC. I send it back to the other side. And then the other side's watch character up here says YZ. And so that's the kind of sequence for the watch characters. So you know how that goes. And you note down here, the bundle ping, the bping program says that we've transmitted one bundle, we received a bundle. That's good news. There's no bundle loss. And this was the time was 3.3 milliseconds over and back. So another fun thing to do if you want, you can go into the bping program and just don't put anything in there. Hit return, and it's just going to go once a second, just like regular old ping does. And on the IP world, so you get regular old ping, and you can see the sequence number, you can see the round trip time. The other thing that you also need to do is you go bping, spell it right, bping, go the other way. So bping And we're just going to go from IPN:2.2 to the background program running BP Echo on node 1. And we will send that then to IPN1.3. And it should start pinging the other direction. And so now we've proven to ourselves that we've got good connectivity in both directions. We've got an ocean of watch characters. And if there was an error or loss in between, you'd see punctuation marks. Very, very clever scheme Scott came up with. Punctuation marks indicate an anomalous condition that may or may not be errors. It might be this bundle was too old and timed out, so I threw it away, and you'll get notifications like that. So this is how you know the two nodes are actually talking to one another. And if we do a Control-C and we stop the bundle ping in each of these windows, and I just do a nice little clear, and over here I'll do a clear, and we can start in with the next step. And the next step is step 9, send and receive bundles. Okay, step 9 is we should already be in node 1, and we should be in the right directory, so we don't need to CD. We're in node 1 and node 2, local node 1 and local node 2 directories. So on this side, I'm going to send a bunch of bundles over to node 2. But I want node 2 to keep track of the bundles and tell me how fast they were coming over. And so over here, I'm going to start a BP counter program. I'm sorry, I'm in the wrong window. I always do that. You'd be surprised how many places my password exists because of being in the wrong window when I typed it in. L node 2, we're going to go BP counter. And all we have to do with a lot of these programs is just tell the BP counter program what our service number is. So our EID. So our endpoint identifier is node 2, and our service number here, 3 was already used for BP Echo. So we're going to pick another number, and that was in the BP RC file. That'll be another homework assignment. But for right now, I'm going to use 4 because 4 is not assigned to anything. So if I do this, it goes, it says, oh, look, I can't open my own endpoint, okay, because it's a malformed endpoint identifier 2.4. So it's another reason to have this tail up there, because then you can go, oh, dummy, it's IPN colon 2.4. Okay, so now it knows what I'm trying to do. And so it's sitting there waiting, and it not receiving any bundles. It's getting really bored. So let's go over here and tell it to send some bundles. So on the node 1 on the left, we're going to type in BP driver, and we're going to tell it, and the man page for man BP driver will tell you what all these codes mean. But we're going to do 1,000, send it 1,000 bundles, and we happen to be IPN colon 1.4, but we're going to send it to the other side, which we know is IPN 2.4 is where BP counter's listening. So we go IPN colon 2.4, and then for all sorts of arcane reasons I won't get into, if we tell it to send 10,000 byte bundles, I go minus 10,000, and it'll just send 1,000 bytes of 10,000. And if I hit return, okay, zoom, it in a gigabit per second, it's sent from the bundle protocol driver program to the bundle program in the same computer. So it was very fast. That doesn't mean anything except for it just works very fast if you're doing everything on the same computer. Notice on the right, it's starting to receive bundles and it counts up to 1,000. There's 1,000 bundles received. And then here's where we need volunteers to go in and scrub through some of these test applications,
I think when you ran BP counter, you needed to tell it how many to stop
Yeah,
at.
you're right. I goofed that up. It's BP counter 2.4, and then you put in count up to 1,000, and then tell me the result.
Yeah,
Do
right.
that here, and then I go back to here and try that again. We'll see that it works. I wasn't following my own instructions in the page 13 of the document. But it's good to show these kind of normal operational anomalies that you have to end up dealing with. There we go. So it counted up my 1,000 10K bundles. So we got 10 megabytes of bundles transferred over to the other side, and it just throws them away. It doesn't save them with this test program. And the throughput between the two is 3.774 megabits per second. And I think in the contact plan, I had it set for like 4 megabits per second max. So that's the maximum bandwidth allocated minus some little bit of processing time that slowed it down a bit. And so you end up with an effective pretty close to 4 megabits per second. Okay, so that would work in either direction. And then the last thing I'll show you before moving on, time, let's transfer a file. So what do we want to do for a file? I'll clear these guys just to tidy things up a bit. And you can see up here, the only new information in the ion log for the receiver was that first time I ran BP counter and stopped it, it just says it stopped. And then the second time I did it and it stopped by itself because it reached the count. It wrote that to the ion log. So you can get a pretty good, between the watch characters and the ion log, you can get a pretty good feel for what's going on in simple network situations. If you've got a bunch of nodes, we've been working on a whole system to do large scale network monitor and control with multiple nodes and displaying things and plotting things and so forth. But we're going to try to release that to open source eventually when we get it done. So now we're going to send a file. So what kind of file do I have? Well, I have a file in here that I put in called testfile.txt. And if I it's just a short ASCII text file. And I just grabbed some data from the Project Gutenberg ebook of Princess of Mars, which was a great book. But they made a lousy movie out of it. John Carter, I think they called it, which is a terrible title. Somebody from NASA must have thought that title up. Anyway, this is the file we're going to send over. And so the file we're going to send over, first off, we need something on the right-hand side to capture that file when it comes over. And so we're going to run bpcpd for the bpcp copy daemon. And it doesn't do anything right at the moment. It just goes, oh, okay. So it's waiting. Doesn't give you any kind of feedback except a carriage return line feed. So then on the sending side, we're going to go bpcp. Now this uses testfile.txt. bpcp uses CFDP. CFDP is designed for an external program to drive it and send a whole lot of files. And then for each file, you can give it all sorts of parameters, whether or not you have a checksum, whether or not you want a response back. I mean, there's a whole bunch of options with CFDP that we don't have time to cover today. But BPCP uses an instance of CFDP under the covers that allows you to just send one file and then we're done. And the nice thing about CFDP is it can also do directory operations. And there's another homework assignment, read up on CFDP because you'll love it. But you can ask for a directory listing of a remote directory. And then given that you have this directory listing of some remote directory, you can say, hey, I want this file to go into that directory, but shoot, you've already got a file with the same name, so I'm going to give it a new name. So what we can do here, using CFTP under the covers, is we say, okay, we're going to copy this test file text over to entity number 2, slightly different addressing convention because CFTP was legacy long before DTN showed up. So I'm going to go to entity number 2, which is IPN node 2, but I'm going to call it renamed text file .txt. Now I could have put a whole path in here, that slash in whatever directory structure I wanted to, but right now it's just going to go in the local your local directory over here. So when I do that, it says starting the copy, and since we've got a pretty good internet speed here over localhost, fortunately, it says it's complete. And over here, I say, okay, well, I don't need this BPCPD anymore. So I'll Control C, stop that. And when I list, lo and behold, here is renamed test file.txt or text file.txt. So between the streaming capability of DTN and the file sending capability of ION, we've got a pretty good package for people to start with. Now you might have to write your own applications because if you want streaming telemetry, you're going to have to just look into what the BP driver software does for taking the information and formatting it into a structure that you hand to Bundle Protocols API. You can look at that as an example. Same thing on any receive software. So this completes the 2-node on 1 computer demonstration. And if I don't see any open questions. There's some questions that were answered, which is good. And I appreciate Samo and Scott stepping into yeah, okay, I was just looking. I hope Jim Burnham got everything.
Yeah, I think everybody has been keeping up, and
Okay, good.
I think everybody is up to speed and ready to go. If you want to go ahead and
Yeah, let's go ahead.
computers.
We'll go ahead to the next one. So for the next one, I'm going to stop. I'm going to go kill him and kill him. And you only need to do it on one computer because it kills the processes for both left and right in one step here. So you can see over here on the ION log, it says it ended the TCP CLA and it closed the out duct. And, so essentially, if you do PS AUX, you'll see that, this K worker thing, you'll see there aren't any, if you spread the window out, you'd see there aren't any ION related, DTN related things running. So at this point in time, we can just clear up a little real estate. And I think I can leave these alone. But stop that. Okay, so I got a fresh window here, and I got a fresh window here. So the first thing we need to do is we're not going to be working out of this node 1 anymore. So the first thing I want to do is let's get back up to our home directory because we have more downloading fun to do. Okay, so those are all cleaned up. We're sitting in the home directory on node 1. So the first thing I want to do on node 1 is I've got to undo that -rc file because we don't need to do that if we're only running one node on a computer. So we just take that out. Otherwise, ION might get confused and be looking for a SDR in some other directory. So we're going to go nano. Let's make sure. Okay. Okay, Laura's got the Yeah, okay, let me follow Laura's instructions instead of my own instincts. Because she has this step later on. Let's follow the official instructions. And the official instructions is, okay, we're going to get this test program. I mean, the directory that we need for the single computer, single ion on single computer.
Hey, Lee,
Yes,
see, I have tried to explain to people, rocket scientists, like herding cats. Your brain is in all these different places and all these different things. I mean, it has been an absolute joy working with you, but trying to follow the path, it's cracking me up watching you trying to follow this
trying to follow directions
step
that
by
we
step instead of,
mutually
oh,
put together.
do it this way. I love it.
Yeah,
Yeah.
there's certain things like you always get on a horse from one side and not the other side. But if you're a cowboy, you can get on either side depending on the circumstance.
As long as you don't try to get on from the back, right?
Right.
Yeah.
Yeah.
Okay, so we're gonna get comp computer one. So it was named comp one, and it's the ion test directory, and it got zipped up, and it's living in https:// magic bit.ly directory or link to C1 dash ion test. Okay, so here's our directory. And if we list now, you'll see that we have this comp1 ion test.zip. So we're going to go unzip, make sure that's in the directions here. We're going to go unzip comp1 test.zip. And there we go. And if we list that, we find out that we don't have ion test. We've got a directory called comp1 ion test. So if I cd to comp1 ion test, and I list that directory, there's my ion test directory. So I need to move that to my home directory. And there's a couple ways of doing it. And just for the new folks in the group, they might be more comfortable doing something like this. If we find that ion comp1 ion test directory up here, and you see the ion test folder, and if you just drag that ion test folder over to your home directory with a little picture of a house and your name, you'll see that that directory's gone. And if I go up a directory and list, you'll see that I've got ion test right here. Okay, so there's the ion test directory. And if I now, on the single computer, cd ion test and list it, you'll see it looks just like the local node one kind of directory. It's got the resource files, RC files that you need in that same test file. And so at that point, you would probably go down and do things cd ion test. Whoops, be in the right window. And each of your other windows here. Now, the next step
Lee,
you got to do for number two. Yes.
oh, I was just gonna say, in the steps, the way we did them, we had them go to computer number one, unzip comp one ion test, and then go to computer number two,
Correct.
unzip that one.
I'm going to reshare so I show both computers,
Oh, perfect. Thank you.
which is share this guy and then wait a minute, where's the other one?
How many screens do you have in your office?
I've got two 34-inch monitors
Okay.
because you can't have too many screens.
You can never have too many screens. Yes.
Yeah, I'm just looking for VNC viewer for node 2, which was right there. Okay. Now that I can see a picture of it, I know what to share. So here's VNC node, this one. Oh, I gotta go under documents. Now it's screens. Okay, there's that one. And there is it's just fighting me. There it is. That one. Now, why is it? It's not letting me share individual windows, which is okay. For right now, just to get on with the show, I'm just going to share I should be sharing the whole desktop. Are you seeing the whole desktop?
Yep, that looks good.
Okay, so I'm
If you want to
sharing.
move your computer 2 windows to the left on that second computer, if you want to, the terminals, sorry. If you want to take the terminal windows and kind of scoot them to the left-hand side, then they'll
Done.
line up really nicely with the other one.
Done.
Yeah, that looks good.
Okay. Continue to march. Now, on this side, I already had it set up from yesterday, and in fact, I'll stop by on. I already had it set up from yesterday. Let's talk about what you have to do with 2 computers. If you've got a second computer and it's your own and it's Raspberry Pi, you can do the steps of building the Ion, copying the Ion test directory over to this side. And by cd Ion test, you'll see it looks just like this one, except it's got IPN1 and IPN2 instead of IPN1. Well, okay, this is a mystery. How do we get IPN1? I think we're gonna sneak over to page 17.
Okay, so I think, Lee, we need to clarify something here, that you are doing a demonstration that would require someone to have 2 separate, separate Raspberry Pis here.
Yep. Or a Raspberry Pi and a Windows or a
Something, some
recommend
other,
Windows, but
yeah.
a
So
Linux machine.
yeah. So for those of you that are following along with the lab, the one computer lab has 2 instances of Ion running within one Raspberry Pi. So you're just going through the loop back there. This time, however, it's like you have 2 physical separate systems on a TCP/IP network. So we're going to need we're going to need the IP addresses of the 2 hosts. And this would have traffic going out of your Ethernet or your Wi-Fi adapter across the network to another physical machine. So when we're talking about computer 1 and computer 2, it's not just node 1 directory and node 2 directory. These are 2 separate machines, and there'll be node 1 stuff running on one machine, and the node 2 stuff is running on another physical machine.
And that's evidenced by the fact that from the background, you can tell that node 2 is in Norway and node 1 is in China somewhere.
I like that. I'm going to use that. I'm going to add screenshots of the 2 computer lab, and I really like that idea right there.
Okay, so here's the deal with addressing. You've got to send stuff over to another computer and not just localhost. So in order to send things over to another computer, in the BPRC file, that's where the directions are for what TCP connection you have to hook up to. And instead of hooking up to localhost and whatever port, you're going to hook up to the IP address of the other computer. And the 2 ways of addressing things in BPRC is I can hook up to another computer by giving it an IP address and a port. And that's that's handy for a lot of uses in a lot of cases. But if you've got a computer that might go down and then somebody brings in another computer and brings it up, gives it the same name, but it's got a different IP address, it's problematic to change a lot of things in several places maybe. So we like to put in the name and the IP address in the local host file. So page 17 says what you've got to do. So I'm just going to open up another window that's larger that I can get rid of later because they're free and cheap. So if I go nano, my favorite nano, and then remembering that, oh, she's got, okay. I'm going to do something first. I'm going to go cat slash Etsy slash hosts. Okay. Yeah. So the first step changes. See, I already did this apparently on this computer because I was testing this morning. First host says local host, and that's of course home, your 27001. So if she said sudo host name RPIO1, and then it's basically, that's what you end up with. It adds in this extra local host IP address and then names it RPIO1. Now, your other computer, our IP addresses are located here. And so she's got the Etsy host files listed on the bottom of page 17, and the IP addresses have to be peculiar to your own installation. And in order to change that, you just sudo, because it's a protected file, you have to be super user to get in there. So you can go sudo nano slash Etsy slash host. And then you can go down here and add in these lines. So you would add in on both computers. You'd add in whatever your local IP address is for your first Raspberry Pi. And then down here, you would add in whatever the IP address is for your second computer, which may or may not be a Raspberry Pi. And then that's how the system Linux will know if you address something to RPIO1 as a socket, with a port number, it knows how to get to it. I will exit this because it's already fixed. Yeah, okay, I changed your second step a little bit. It's already fixed. Let me show you real quick. If you go IPADDR, it shows you what your IP address is and a whole bunch of other stuff that nobody knows anything about. I'm kidding. ETH0. So Ethernet 0 is the Ethernet port you've plugged into. If you're on Wi-Fi, it'll have another identifier, but it'll give you your internet address right here. And in my case, it's, since I'm wired on the wired internet on the local lab LAN, it's 170 and 171, my two computers. You're going to have to put in whatever your IP address is, which you can determine from this IP address command. So why do we do that? Well, here's what we're going to show next. I moved this ion test file out of this comp1 ion test folder and put it in the home directory where I'm used to seeing it. And I didn't tell Laura, so my bad.
I know.
If we go down to the bottom of page 18, and on either computer, we're going to do, I'm going to move this aside a little bit so you can see both at the same time. So on either computer, I'm going to go edit first off, I'm going to list where I am. Oh, I'm not in the right directory, so I got to go cd ion test instead of what Laura said, because I moved it. And if I list that, you can see we've got the IPN1.bprc file in both sides. So over here, I'm going to go nano, since I own it, I don't have to sudo nano it, IPN1.BPRC. And then over here, I can do the same thing. Okay, I'll have to go through the bash files and try to figure out why we've got different colors between these two machines. That's because I configured things without really knowing what I was doing. Which reminds me, by the way, for any newcomers to Linux, ChatGPT is your friend. Uh, ChatGPT normally comes up with the right answers on how do I do this in Linux. Sometimes it doesn't do it the slickest way, but it seems to work pretty well. If I go through this file, the first thing we have in the BPRC file is we tell it we're going to use the interplanetary network IP and naming scheme. We've got some stock names for some files that ION uses, and we're going to define a bunch of, this is like ports. If you tell a TCP stack, or I don't know how that works with TCP, but it's essentially the service numbers. So we're going to reserve service number 1 through 12, 0 through 12. And then for the asynchronous message services, we use 9 and 15. And for CFTP is 64, 65, so forth. These just kind of come stock. And you can change those numbers to whatever you want. Eventually, they're going to have like the IANA well-known ports, where port 22 is SSH. We're going to eventually standardize across the DTN world on some service numbers, but we're not quite there yet. So after setting all that up so BP knows what to do with what numbers it can use to send things to applications, we're going to go down and look at the protocols and the ducts. And we were trying LTP and it got fairly complicated to explain, so we decided just to use TCP. So I commented out the provisioning of LTP in both these files. So now I have TCP, and just to kind of line them up, I made this smaller so the font's slightly different. But anyway, you first off add a protocol. You tell bundle protocol software to add a protocol called TCP, and it goes, okay, I know how to do that. And then you say, okay, for the induct, I'm going to use TCP to listen for anything coming in with bundles. And I'm going to I could use my own IP address, or I could use localhost, or in this case, we're using 0.0.0.0, which listens to anything using IPv4. If you've got multiple Ethernet ports on your machine, this would pick up all of them and anything coming in for port 4556. We can get in long security discussions about whether or not that's a good idea, but that people have been doing that for a while just because it's convenient. I'm going to listen on port 4556, and I'm going to use the TCP convergence layer interface to the TCP stack to get my data. And when I send data out, I'm going to go out through the TCP stack, and I'm going to go to Raspberry Pi number 2, or ION node RPIO2, and I'm going to send out on a different port. And we don't need a name there anymore. It was deprecated. So if you look on the other side, this is always a good check if things don't work. You look on the other side, okay, induct, I'm listening to port 4557, and over here, I'm sending to port 4557. And that makes sense. And then I'm over here, I'm going to be sending to 4556, and I'm listening on 4556. So that's the meaning of that little diagram on page 19. And some of the text explains what I just said anyway. So that should take care of configuring your two computers. If you've got the correct IP address for the other computer, and you got the ports kind of cross-wired like this, then you should be in good shape. And then down here, the plan is, what's the plan? How do I get to IPN1? I say, well, okay, I need to put together a plan to get to IPN 1.0, which is the administrative node on the other side. And the way I'm going to get to that node is I'm going to address to IPN 1.0 over TCP. And that's just the socket, essentially, the bundle protocol. We'll get this out of this IP socket. And then starting the watch characters, this is where all these letters come in. You can have that 0, or you can put in the particular letters you want. You can read the manual on that. And then start is the final starting gun goes off, and we're off to the races with ION. So the next thing is find the control X. Same thing over here, control X. So the next thing we need to do on this computer only, okay, because this was the computer that had the 2 nodes on one computer. And remember, we had to do that bash RC business and all of that. That was kind of a interesting exercise, but now we got to undo that. So the way we undo it is we're going to go nano. And remember that the bash RC file lives up in your home directory .bash RC. And here's the famous bash RC file that we played with. And we go down to the bottom where we added that one line and we just commented out. Okay. And that's all you got to do for the bash RC file. And then you go Control O to write it out, hit return, and Control X to get out of nano. And then, since all these terminals were sourced with the other bash resource file, you really need to do source.bash RC. And since it's in a funky directory, we got to go /bash RC. And I'm going to do my middle mouse button trick on all these terminals, and then just go return, 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 return. And then that should clean up all these 4 windows to be a single node on a single computer type situation. And we can do PRINTENV just to make sure. And it didn't work. Why didn't it work? /bash RC. It should have restarted that. Aha. Okay, it did work that time. No, it didn't. There it is. What's going on? Let's just.
It may be okay because the other node you're talking to is on another machine, and as long as you don't reference that node by its old name, it may not matter that environment variable is still there. I would say
Okay, there's some. It worked because the environment variable is not there.
okay.
So it did work. We just have to 1, 2, 3. Okay, we just have to restore our happily sized windows, and then go CD ion test in all of them. And then we're ready to rock and roll. Okay, that pretty much concludes page 19. Okay, we'll try to scoot on because we're pressed for time here. So back to the same thing on both computers, just to be sure, do chmod +x ion start and spell it right. Okay, so that should take care of this computer. The other computer's already got the ion start script is already executable right there. So with this, we can now go over here. And since we're looking at the whole screen, I don't have to have those over to the right anymore. I can move them over here. So we're just going to go, we killed Ion there. And so over here, we're going to go Ion start and see what surprises await. Ah, looks okay so far. Ion start. See what surprises await. And then we go tail -f ion.log. That looks good. Over here, we're going to do the same thing. That looks normal. And then over here, we're ready to not do anything. Well, let's see. Yeah. We'll be ping. Here we are. We got pinging going from one computer to another computer on independent nodes. And on this side, we can do the same thing. That just sent one bundle and it worked. But if I want to have lots of watch characters to look at, I can do that. So there's the connectivity proof in both directions between the two, the computer in China and the computer in Trondheim, or thereabouts. And Control C and Control C. And I could go through, everybody's already seen the other demos that we did on the two computers, and it works the same way with this. So I think this concludes the two computer, one Ion on each demonstration. And please contact me, if you got any problems getting these things set up. I'm happy to help over email or whatever. In 5 minutes, I'm going to just go through the last couple pages of our magic instructions that Laura so beautifully put together. And the one thing I noticed when I was doing testing is that I had two Raspberry Pis and things were going pretty fast in one direction, but kind of slow in the other direction, which was annoying. And then I realized, oh, Raspberry Pi has a bunch of different clock speeds for the CPU, 1.5 megahertz all the way up to 2.4 megahertz in discrete steps. So you can have it run at the performance level, which is the 2.4 megahertz. And there's a way of setting that, and their instructions are in there. You have to download something called CPU Freak Utils from the Raspbian repositories. And then when you do that, you can set it for performance, which you'll set it at 2.4 megahertz. And then you get both computers going as fast as they can. The warning is that you really need to put a case and a cooler on these things when you're running at 2.4. If you don't, and it's just sitting out there on the table, it'll be kind of hit and miss on the CPU will throttle itself down to back to 1.5 if it overheats. So, get yourself a little $20, whatever the local equivalent is, case with a fan and some heat sinks, and go to town. If you want to have a headless Raspberry Pi, if you don't have a monitor and a keyboard, and all you got is Wi-Fi, you can set that up with the Raspberry thing. But if you want the SSH, you really need to have a monitor and a keyboard, unless you set it up as a purely headless with no monitor and keyboard Raspberry Pi. And there's a huge amount of documentation on that on the Raspberry site. If you do a lot of these tests for a long time, you'll find that SSH might time out if you've been reading the man pages and you haven't done anything with your SSH connection in a while, it'll go away. So you can fix that on this bottom section on page 21 by basically going into the sshd_config file and changing the client alive interval to that's 1 million seconds, so some big number. And uncomment the client alive count max settings. So that's a little helpful tip. And then the last little tip that Laura put in is it's Raspberry Pi is pretty good on letting you know that your operating system needs updating, and so is Ubuntu. Ubuntu does it all the time. Drives me nuts. But if you ever need to do it manually, there's steps to do it manually. Two last things. One is Ubuntu. If you want to run Ubuntu, VLC does not work with Ubuntu 2404. You've got to use RDP with Microsoft RDP, because they mutually, between Raspberry Pi and the VLC people, they all decided that it was insecure the way they had it packaged up. So when you download the Ubuntu 2404 from Raspberry Pi's installer, you have to manually install SSH and get that working yourself, and you have to manually install the remote desktop software and get that working yourself. And that's a little bit of a push-up. Other than that, the dependencies work okay, and you use Ubuntu 2404 all over the place here, so everything works fine on Ubuntu. It's just a kind of a pain in the neck to get it configured so you can have a remote desktop window into your Raspberry Pi and have SSH work from your remote computer. Your mileage may vary with other distributions. It works fine. Ion works fine on Oracle. It works fine on where we use a lot of Oracle 8 installations. It works fine on Red Hat, if you can afford Red Hat. And of course, for these exercises, if you don't have the security concerns that some people have about Ubuntu and Raspberry Pi OS, these things work fine. Last thing is there's an event survey. You can fill it out more than once. And if you go to the event survey and have any questions, or you want to see more, we're thinking about another session like this where we could spend the whole session doing nothing but configuration files for Ion, because it's a black art. LTP, tuning it up for your long distance hops, is also a black art and takes a lot of discussion on how to do LTP. How to use CFDP. We've got a CFDP test application that reads a script that's very easy to manage. You just put this little script together and name all the files you want to send that over to CFDP test and run it. And CFDP, you don't even have to run anything on the other side because CFDP is already running, and it'll transfer all those files for you. And some people might like a demonstration on that for their particular application. But anything else you want or can think of, put down in that event survey, and we'll see what we can do about it.